Welcome everybody to our latest in the range of our Ask the Expert videos. My name is David Pike, the Connect Geek, and I'm joined today by a couple of guys to talk about antenna. Now, if you have any device that connects to the internet wirelessly, it uses RF communications, which means it needs antenna. And so antenna are everywhere around us. To talk to us today about antenna, I'm joined by two guys from TE Connectivity, Gabriele Giuliani and John Hunter. Welcome, chaps.
Thank you very much. Thanks for having us.
Brilliant. And I'll give you a couple of minutes just to talk about TE Connectivity and your role in the world of antenna.
Yeah, no problem. So TE Connectivity is probably one of the largest companies you've never heard of. We have components for just about everything, electronic as well as passive, including antennas. I actually came from an acquisition just over a year ago. So I used to be part of a company called LED Connectivity. TE acquired the external antennas business, and we now operate as the name LED External Antennas, now part of TE Connectivity. So we have a broad range of antennas ranging from sort of the VHF, slightly lower sometimes, up to 7 gigahertz range is kind of our sweet spot. And every shape, style, size of external antenna you can imagine.
Well, that launches us into the first question, actually. With so many different antenna options available, what is the role of the antenna in modern technology?
Basically, the antenna, as you mentioned before, is in any device connected with the wireless technology to the network. And so the antenna has a crucial role because it allows all the informations to go through the network. And moreover, nowadays, we always speak about energy consumption and so on. So a good antenna will also allow us to have less energy into the antenna itself. And so to be in the network, not exchanging informations all the time, like for the cellular network. So, you have to say to the network that you allow to exchange data. And so a good antenna does that just once, and then you have all the channel and all the throughput going on with the data. And so that's why we do have, within Europe, we have a full team serving our customers to let the customer to have the right antenna in place on the device, and so to maximize the efficiency of the devices. So not only looking at the peak gain and all those details that you may find in the data sheets, are also helping our customers to find out what is the best antenna for the device.
And so with so many different antenna, and again, so many different reasons to have it in modern technology, there must be some really interesting applications for antenna at the moment. One of the things we're hearing about a lot is the Internet of Things, or IoT. How does that get involved with the world of antenna?
Yeah, so IoT it's originally, when it first came around about 10 years ago, it was kind of smart devices. It's your fridge being able to connect to your phone and tell you the humidity level or temperature in your fridge. And now we actually refer to the Internet of Everything, because everything is now connected. There are not many devices, especially electronic devices, that you can buy nowadays that are not a smart device. So IoT is a bit of a catch-all term which has a lot of markets and applications within it. Any device that communicates with another device, in theory, is an IoT device. We see a lot of different types of IoT device. I guess one of the things we're seeing now is a lot more digital signage. Things out on the street are now connected. The fact that it is connected means that you don't have to have a person going out to maintain. If you've got a digital display, you can emit from a computer 1,000 miles away, however many miles away, you can change the display on that screen. You don't have to have the guy going out pasting the new billboard up on the screen. So any device that connects to another device, in theory, is IoT. But there's a lot of applications within IoT.
Well, that actually brings us on to the subject of areas for this kind of technology that's away from the customer eye. We're all used to having smartphones. We're used to digital billboards. But there are lots of applications for this kind of technology in other worlds, in the world of industry and automotive, that members of the public wouldn't necessarily be aware of. How are antenna helping those applications?
Yeah, well, David, basically, you just mentioned smartphones. And in the end, every time we speak about 5G and also IoT, the word smart is always there. Smart buildings, smart cities, smart companies, smart agriculture, everything to be smart has to have a very high degree of exchanging of informations. And the best example I can give you today is, for example, in the automotive. We are going to go to have autonomous driving, right? Today, the autonomous driving is basically on the sensors. So you have your sensor, several sensors in the car, seeing what is the environment, right? In the future, we will have the antennas on the cars and also on the buildings, knowing how the environment is, because we will have antennas with a high precision GNSS. So every car will know exactly, with information that are on the 5G network, where the other cars are. And so with all those data, IoT data in the end, the car will know where there is a space to go through, or if we have to stop. All those things together, so all those devices together will exchange informations at some level that today is not possible. 4G is, is okay if we have to go through internet, so with our smartphones, for example. But if we need more bandwidth and also we increase the number of devices, the 4G network is not okay, is not enough, let's say. That's why the 5G will play, and it plays already a big role, because there is a space for many other devices in the end, and we can exchange information with very low latency. That's why the autonomous driving, for me, it's a very crucial example, because you don't want to have 1 second delay to know if you have to stop the car, right? So low latency and very high throughput is the key. And we can extend this technology to all the smart buildings applications. So with the sensors knowing if the humidity or the temperature is within some range, so we can even arrange the power consumption. I mentioned before, so the energy today is the key. How you use the energy is the key. And as I mentioned before, battery life is going to be even more crucial in the future. It's already our life. You don't want to charge your phone 10 times per day, and also you don't want to power all the time on your devices, electronic devices in your building, to make it fresh or warm if the temperature is already okay. All those things within the 5G network and the IoT are possible because the devices, through good antennas, will be connected all the time and with very high throughput and low latency.
We've talked about 5G, and I think a lot of people will imagine that the 5G network is just a global thing, and we use smartphones and all these other devices. But 5G is enabling other kinds of connectivity, including things like private networks. I'm guessing antenna are just as important for those applications as well.
Yeah, absolutely. I mean, especially 5G networks. If you're wearing, a private 5G network, if you want to operate a private 5G network, it operates on an extremely slim spectrum, part of the spectrum. So if you have an inefficient antenna, it's not accessing that spectrum efficiently. Your communications to and from a base station antenna and a private network, for example, are not going to be as efficient. You'll have dropouts, latency is affected. Whereas if you get the right antenna, high performance antenna, all of those things are sort of negated. You have the data throughput, you have the efficiency, you have the reliability. and also ruggedization. We build extremely rugged antennas for private networks. If you're in a warehouse environment or an industrial environment, the levels of shock, vibration, humidity, dust, they're far increased compared to an antenna that might sit out on the street. So we do over engineer some of our products, I would say, to meet some of the most demanding applications. That being said, we have everyday IoT antennas for the less demanding applications. So we have everything to suit. But if you want to operate a private network, I guess one of the main things you don't want to be doing is maintaining it all the time. You can look at the cost of an antenna and think it's quite high. But if you have to send a maintenance person to look at the antenna and look at the system twice a week, you're paying their labor twice a week, or however often it is, it totally negates the cost of the initial investment of the antenna. It's an undervalued component of a communication system, I would say.
And you've given us a couple of examples of the kind of environment where we might see a private 5G network in an industrial or a warehouse. Do you have any examples of the kind of people who might employ a 5G private network, who would be interested in that kind of functionality?
Yeah, I mean, so private network operates on a licensed frequency, so it's more secure. Unlicensed spectrum is standard 2G, 3G, 4G, 5G, open to anyone. So if you're operating on one of those frequencies, your systems can provide some level of security, but you are operating on an open frequency. If you work on a private network, obviously it's effectively a spectrum license to you. You will get large companies. So if there are large companies that have lots of large campus areas or warehouse facilities, they will operate on their licensed part of the spectrum, and just keep that private network within the buildings. It's usually something that's adopted by larger companies, but in theory, anyone that can purchase a slice of the spectrum can operate their own private network. And really, the benefit is increased security. If you're operating in an environment that might supply military or security products, you want that data and those communications as secure as possible. So that's one example, but there's certainly commercial applications where companies would not want their communications and their data leaking out to the open market. So in theory, they're open to everyone. There are more specialists than just taking the unlicensed spectrum, but there's a multitude of different companies that would, or individuals, or organizations that would take up a licensed or private network.
And you've mentioned that some of these companies, some of these organizations that are using a private network, they might be deploying it across a large campus. So you've got people who are moving in and out of buildings, people who are moving in and out of warehouses, potentially even inside vehicles moving around the campus. And I think when we were setting up the call and when we were doing some of our preparation for this call, you were talking about different antenna for different environments, inside the building, outside the building. What technologies do we need to use, or do we need to think about when we're deploying antenna for these different environments?
Yeah. So talking about the Internet of Things, we just mentioned 5G. In the end, the Internet of Things will embrace 5G, Wi-Fi, and also GNSS. So if we keep the smart buildings or campus environment, we can mention that knowing where the car or where the people are can be interesting data. That's why we do have antennas that are multi-ports, we say. So an antenna that is with inside several elements to cover, for example, 4x4 MIMO for LTE, 4x4 MIMO for Wi-Fi, and the GNSS high precision on top, and the ISM band for the LoRaWAN network. So having those antennas will let us to know more than one information, let's say. So we may use the 5G to be connected to the network itself, the GNSS to get the coordinates, the position of the device, the person, the car, and the bus, and so on, and the Wi-Fi to also let people to have high throughput connection through the Wi-Fi, because do not forget that with the 5G, it won't be enough to have the, let's call the base station far from our campus. We need some more, some closest point to access the network. And that's why an antenna with a, for example, 4x4 MIMO Wi-Fi, it's very interesting in those environments, because we will still have very high throughput, because our access network, it will be not the base station, 500 meters away, but it will be the one 50 meters away on top of our building. Okay, so we do have, for example, the GAR and Barracuda antennas in our catalog that allows the customers to play to place the antennas on vehicles, for example. Those are very, very good for the automotive environment, as well as for smart buildings or smart cities in general. So that's why we do have multi-port antennas.
And you've also brought up the fact that these antennas are going to be mounted in different places, on vehicles, on buildings. And one of the things, Gabriele, that you mentioned when we were planning for the call is that it matters enormously what you're mounting these antenna to. So can you explain a little bit more about that?
Yeah, so it's crucial when you have to think about your system to know the environment where the antenna plays. And that's why for several of our products, we do have the version ground, on the ground, and off ground. So another example, we mentioned the GAR antenna that for vehicles application, but it's probably easier to speak about our phantom antenna that is for the 5G network or for Wi-Fi, for example. We do have different products, the one on ground and off ground, and in the end, for radio frequency people, it's let's say easy to understand. But to make it easier, when you have an antenna, you have two elements. You have the radiation element, and then you have the reflecting elements, let's say, that is the ground. Okay. Sometimes you have the metal plate, the car roof, for example, or you have your smart locker under your house that has the metal roof, or you have a ticketing system with a smart with a metal roof. In this case, you already have the reflection plates, and the antenna, the no ground phantom antenna, for example, for you is okay, because you already have the metal plate under the antenna. When you have a plastic, you have a plastic chassis, you need an antenna for example, smart metering. Okay, so for smart metering, usually the chassis are plastic one. In that case, the antenna that is made for the ground one is not performing well. And as we said from the beginning, the efficiency is going to be the key. We made an antenna which is no ground. So we do sell the antenna with the reflecting element inside. The grounding system is already inside the antenna without even changing the shape. So the real good feature for our phantom antennas is that you will have a black or white antenna element with exactly the same size. So you may even think about your system to be placed on plastic or metal enclosures without even changing, the shape itself. So from even the looking point of view, you will have a consistency on your system.
That's interesting. I really like your explanation of how what you're mounting these antenna to makes a big difference in terms of the product that you're choosing to get the greatest possible efficiency. Let's look just briefly at the future, because 5G is with us at the moment, but it's not staying static. 5G is not the end point. We're hearing people talk about getting more out of the 5G network. I started hearing people talking about 6G. So what can engineers do to prepare for the future? Because I'm guessing antenna will also need to evolve to keep pace with the technology that they're deploying it for.
Yeah, that's right. So what I would say is don't design your products or your systems for the current offering. 5G, for example, we use up to about 4 gigahertz at the moment, but the spectrum has been allocated over 7 gigahertz. So we have that additional 3 gigahertz frequency that is not really being used at the moment. It's kind of available, but and then some of it is future rollouts. So in the next 5, 10, maybe even less years, that full range of spectrum will become available. So what we do for 5G products is we design them to be global, so they cover the full 5G spectrum that we know is allocated and available. So for a global coverage, we usually go from 617 or 698 megahertz all the way up to 7125 megahertz, 7.1 gigahertz. And what that does is it effectively future-proofs that antenna and that system for the future rollouts. So if you put the antenna out now, it can be used up to 4 gigahertz, 3.8 gigahertz, whatever the frequency is that you're using. But then that further frequency is then still available. So that antenna can then sit out in the field, doesn't have to be maintained. And as I said before, maintenance is way more expensive than the actual antenna itself. So if you can put in that future-proof product, it is then available, or the frequency is available from that antenna, all the way up to what we know is the allocated spectrum. And it's the same with Wi-Fi. We've only just seen the rollout of Wi-Fi 6E, which is the first frequency extension in a very long time. But people are now talking about Wi-Fi 7. People are developing products for Wi-Fi 7, and Wi-Fi 7's not available to the open market yet. So it's the same with all frequencies. They're expanding at a much more rapid rate than we've seen in many years. And it's to meet demand. That demand is always going to be there. So the frequency allocations, the rollouts, that's always going to be an evolving thing. So going back to the original point, if you're building a system that you want to use on 4G now, the cost is not a lot greater to expand it to cover 5G and all future rollouts of 5G. And same for Wi-Fi. If you have the capability, you can, if you're only looking at single band Wi-Fi, look at the dual band, look at Wi-Fi 6E, and look at the difference in actually making your system operate over future availability. It future-proofs that product and stops any additions or changes to that product having to be done to make it operate. So just think forward instead of looking at what's available now.
I think that look at the future is the perfect place to end, because it is true that demand is just going through the roof. We see it all the time. Everybody wants more data. Everybody wants greater speed. And with some of these applications that we've talked about, the future of automotive is just one example where low latency, high speed data communications is going to be crucial to the growth of autonomous vehicles. And then if we go into other applications, the use of private networks, the use of these 5G and wireless communication systems for industrial users, there is going to be a constant need for better and better antennas. And I was really interested to hear about how different antennas need to be used for different applications, how these things are mounted is crucial to the choice that you make in terms of the product. So thank you so much to Gabrielle and to John for your help in understanding these antenna technologies. If you need some more information, please go to Design Spark. There's tons more information about antenna. We'll put some more information about the TE connectivity products that we've talked about today. Take a look at the RS website where the TE connectivity antenna are available, and you can see the kind of products that you can get hold of today. And do bear in mind John's advice to don't just look at what's available for now, look at what's available for 5 years and plan ahead. So John, Gabrielle, thank you so much for your time today.
Thank you very much.
Thanks for watching, and we'll see you again soon.